Hello student, I am Bishwajit Bhattacharjee, Physics faculty of AEP team. Today we will discuss the chapter Unit Dimension, which is continuation of previous class. And in previous class you know that we will discuss about the quantities which are divided into two sections. One is fundamental quantity and another one is derived quantity. You know the which are fundamental quantities, and there are 7 fundamental quantities, you know. As well as we discuss about the derived quantity. Which are derived quantity? There are so many derived quantity, right? And then we will discuss about the dimensional analysis, which is basically today we will continue this subtopic, that is dimension analysis. We last class we already discussed some numericals about the dimension analysis, and we will continue this. Okay, so today's class the subtopic is dimension analysis, and we will discuss some numericals about the which already discussed theory, which already discussed in previous class. We continue from this class. Okay, that is a numerical. Say A equals to, there is a equation, A equals to B plus CT plus V square. Okay, V square, and then T and V are the time and velocity. The dimension, you have to find the dimension of A, B and C. Already we in last class we solved this type of numericals, right? So first you try to solve it. You know that there is a summation of 3 terms, like A, B plus CT plus V square. And you know that in case of summation all the terms are in same dimension, right? So here the dimension of A is same as the dimension of V square, right? So the dimension of A is same as the dimension of V square. As also B has same dimension as V square, right? A and B which are same dimension, that is V square, right? V square. That means V is velocity, which is which has dimension LT to the power minus 1. You know that, whole square. So dimension of A and B. So dimension of A and B will be L square T to the power minus 2. Is it right? Okay. Next, what is the dimension of C? And you know that C into T is equals to V square. So C will be V square into V square by T, right? V square by T. That means V square is L square T to the power minus 2, and T by T, that means L square T to the power minus 3. So the dimensions are L square T to the power minus 2 and L square T to the power minus 3. So option 1 is correct, right? Option 1 is correct. Okay, next one. This is basically a question from previous year JEE question. If P, Q and R are physical quantities having different dimensions, okay? These are the 3 quantity which have different dimensions. Which of the following combinations can never be meaningful quantity? You know that if there is a summation or subtraction, then the terms will have same dimension, right? Will have same dimension. Here say option B, P and Q. If P and Q, product of these two, has the dimension of R, then you can solve this problem, right? You can solve this subtraction. In case of this value, you can, if there is no dimensional matching, same dimension, but you can do the product or divide the terms, right? So it may be right, okay? It may also right, because if P and R, the dimension of P, product of P and R is the same dimension of Q square, then you can do this minus. So it may be right, but in this case, option A, in this case, there is a P minus Q, which is not possible if P and Q are different dimensions, right? So this is not meaningful. So option A is correct. This is not, can never be a meaningful quantity. So option A is correct. Okay. Next question. What are the dimensions of A by B in the relation F equals to A root x plus bt square, where F is the force, x is the distance, and t is the time? You know the process, right? Already we discussed this type of numericals in previous class, and you know the dimension of x and t. You have to find x, t and f also, you know. But you have to find the dimension of A and B, right? First, and then you have to find dimensions of A by B. So the equations is F equals to A root x plus bt square. You know that there is a summation of these two terms. So in this term has same the dimension of this term, and also the same of dimension f, right? That means A root x have the same dimension with f. So x will be f square, sorry, you have to find A, dimension of A. A will be f by root x. F is m L t to the power minus 2, and x is L, distance, so L to the power half. So the dimension will be m L to the power half t to the power minus 2. That is the dimension of A. And what is the dimension of B? You know that bt square has the same dimension of f, right? So B will be f by t square. F by t square. F is m L t to the power minus 2 and t square. So this will be m L t to the power minus 4, right? T to the power minus 4. So what is the dimension of A by B? A by B, dimension of A divided by B. A has dimension m L to the power half t to the power minus 2, and B has the dimension m L t to the power minus 4, right? T to the power minus 4. So cancel. L power will be L to the power minus half, and t power will be t square. So L to the power minus half t square, that is option B is correct, right? Option B is correct. Okay, very important sum. Next we will discuss about important use of dimension analysis. Already we discussed that dimensional analysis has many uses, right? And there is a one point which is you can establish a relation between some quantities, right? Like for example, say there is a wire and a stone tied in this at this end, okay, and it is wheeled in a horizontal circle. It is wheeled in a horizontal circle. Then you have to give a force on this wire, right? Give a force on this wire. Basically this force is known as tension force, okay, tension force. This is tension force on the wire. Tension force on the wire. And if mass of the stone is given, say mass of the stone is 50 gram, say length of this rope is given, say length of the rope is 2 meter, and the velocity in which the stone wheeled, say the velocity is 10 meter per second. Then you have to find the tension force on the wire. In this case, first you have to derive a relation between these quantities, right? Here tension force which is written as T, tension force depend on 3 factors, okay. One is the mass of the stone, mass of the stone. Another one is length of the rope, and another one is velocity of the rotation, okay, velocity of the stone. Say length of the rope is L and velocity of the stone is V. So if you find the value of T, first you have to make a relation between mass, length and velocity with the tension force, right? That means first we have to derive a relation. Say tension force is directly proportional to m to the power a, L to the power b, V to the power c. So you have to take a constant, say T equals to K into m to the power a, L to the power b, V to the power c. So this is the relation between the tension force, mass, length and velocity. First you have to find the value of A, B, C, right? A, B, C. Say in this case you know that the relation will correct if left hand side and right hand side have the same dimension, right? So left hand side, dimension of left hand side, so dimension of left hand side is the tension means A force, that is m L T to the power minus 2, you know that, right? This is the dimension of left hand side. And what is the dimension of right hand side? Right hand side, that is m to the power a, L length, L to the power b, and velocity is L T to the power minus 1 whole to the power c. So here this will be m to the power a, L to the power b plus c and T to the power minus c. See, in left hand side the dimension is m, lt to the power minus 2, right? In right hand side, the dimension is m to the power a, l to the power b, t to the power minus c. If you compare these two, here power of m is 1, here power of m is a. So you can write a equals to 1, right? And power of l is 1, here power of l is b plus c. So b plus c is equals to 1, and the value of t has power minus 2, here minus c. So we can write minus c equals to minus 2. So c equals to 2. If you put this value c equals to 2, then b will be 1 minus 2, that is minus 1. So here a equals to 1, b equals to minus 1, and c equals to 2. If you put this value, then we make a relation between these terms, right? T equals to k into m to the power 1, l to the power minus 1, and v to the power c, that is 2, right? That means k into m v square by l. So if you know the value of m, v and l, you can find the value of t. But here another term k, which is constant. Basically experimentally k, the value of k is 1. So the relation will be t is equals to m v square by l. T equals to, actual relation is t equals to m v square by l. We will derive this value in a chapter which is called circular motion. Okay, so here the value of k is 1, so the relation between these three is t equals to m v square by l. If you put this value, then you can find the value of t. Okay, this is very important uses of dimension analysis. Say in next problem, same type, if dimension of critical velocity of a liquid flowing through a tube are expressed as eta to the power x, rho to the power y, r to the power z, where eta, rho and r are the coefficient of viscosity of liquid, density of liquid, and radius of the tube. I know that you don't know the dimension of coefficient of viscosity, right? Because it is a new term. But in previous class we already discussed the dimension of this term, dimension of this quantity, that is coefficient of viscosity. Okay, I think coefficient of viscosity has the dimension of m l to the basically in previous class we already discussed F equals to eta AV by R, right? AV by R. This, from this relation we can find the dimension of eta. Eta will be F into R divided by A into V, that is m l t to the power minus 2, R is L and A is L square and V is L t to the power minus 1. So L square cancel, there is L cube. So m L to the power minus 1 t to the power minus 1. This is the dimension of eta. Okay, you can use this dimension. Rho is the density, you know the density, and r is the radius of the tube. So first you try to do this. It is same of previous problem. Okay, that means here you have to find critical velocity which are depend on the coefficient of viscosity eta and rho and r. It is density and radius, and it is given the relation is Vc equals to eta to the power x rho to the power y and r to the power z. Okay, it is given. So you have to establish a relation between these quantities. Okay, first thing, same way, left hand side and right hand side will be same dimension. So critical velocity has dimension L t to the power minus 1, and in case of right hand side, first eta has the dimension that is m L to the power minus 1 t to the power minus 1 whole to the power x, and rho has the dimension m L to the power minus 3 whole to the power y, and z is the radius, so L to the power z, right? If you calculate this value, m to the power x, L to the power here minus x, and this case minus 3y, so minus x minus 3y, and t to the power minus x plus z, sorry, not plus z, that is L to the power minus x minus 3y plus z, right, plus z, and t to the power minus x. And left hand side, right hand side have same dimension. So what will be the value of sorry, m here, there is a m, right? So m to the power x plus y, I think that is right. M to the power x plus y, L to the power minus x, L to the power minus 3y, and plus z, and t to the power minus x, exactly, right? So if you compare these two, m, there is m has power 0, so x plus y will be 0, 1. Number 2, minus x minus 3y plus z is equals to 1, and minus x is equals to minus 1, x equals to 1. If you put this value x equals to 1, then y will be minus 1, right? So here x equals to minus 1 minus plus 3 plus z is equals to 1, z will be 2, 1 minus 2, that is minus 1, right? So the relation will be Vc equals to eta to the power x, x is 1, rho to the power y, y is minus 1, and r to the power z, that is minus 1. That means eta divided by rho into r. Okay, this is same type problem which is already discussed in previous case, right? And another one which is very important, like this type of problem. Say we know that the already we discussed in previous class the basic or fundamental quantity which are mass, length and time, right? But here say these three quantities are not fundamental, and fundamental quantities are given, that is force taking dimension of force you have to find, and taking mass, time and velocity, as fundamental quantity. Okay, you have to take mass, time and velocity are the fundamental quantity, and you have to find dimension of force. Okay, so in this case you can write F is equals to something constant, sorry, K something K F equals to say m to the power a, t to the power b and v to the power c. This is the relation between these terms. Okay, so left hand side, in this case left hand side has dimension force, that is m l t to the power minus 2, and in this case right hand side will be m to the power a, t to the power b, and a v velocity is l t to the power minus 1 whole to the power c. So this will be m to the power a, t to the power b and t to the power b minus c, right, b minus c, and l to the power c. Okay, if you compare these two, then we will find a equals to 1. Here a power of m is a, here 1, so a is 1. Power of l is c, and here 1, c is also 1, and t obviously b minus c equals to minus 2, right, b minus c equals to minus 2, so c is 1, so b will be minus 1, right. That means the relation will be F is equals to m to the power a is 1, t to the power b is minus 1, and v to the power c is 1. That means mvt to the power minus 1. That means option A is correct. Okay, this type of question is very important. Next, there is a same type of question, like if velocity, time and force are chosen as basic quantities, then you have to find the dimension of mass. It is the same type of problem, right? It is the same type of problem. That means mass, say m is equals to, the given relation is v to the power a, t to the power b and f to the power c. Okay, f to the power c. So left hand side has dimension m, okay, and right hand side, this will be v is velocity, right, v is velocity, that is l t to the power minus 1 whole to the power a, t to the power b, t to the power b, and f is the force, which is m l t to the power minus 2 whole to the power c. That means this will be m to the power c, l to the power a and c, so a plus c, and t to the power minus a plus b minus 2c. This is the relation. So first you have to compare. Left hand side has relation m to the power 0, sorry, m to the power 1, l to the power 0, t to the power 0. So if you compare these two, c equals to 1, right, c equals to 1, and a plus c equals to 0, right, a plus c equals to 0. That means a equals to minus 1, and another one power of t, that is minus a plus b minus 2c. This will be equals to 0, right? This will be equals to 0. So a equals to minus 1, you have to put this value, that is 1. B minus 2c means minus 2 equals to 0. That means b will be plus 1, right? So the dimension will be, dimension of mass will be that is v to the power a, v to the power a is minus 1, v to the power a, and t to the power b, b is 1, t to the power b, and F is the force. So force F to the power c. C means c equals to 1. So the dimension will be v to the power minus 1 a t f. Which one is correct? V to the power minus 1 t f. That is option D is correct. Okay, option D is correct. So these are the application of dimensional analysis. In next class we will discuss about the error analysis, which one is very important part of this chapter. Okay, that's it for this class. Thank you.